Is this possible?
Yes, sir.
Okay, so we were doing alcohol phenol ether. Today's date is 24/10/2025. We are starting at 8:06 p.m. Okay, so though we need to do revision, but at the same time, I'm trying to cover portion, not just because I'm in hurry to finish the portion, but more than that, it's just key we can solve more number of questions. Okay, so start with the alcohol phenol chemical property. So topic name is chemical properties, and you will notice one thing. In case of organic chemistry, once you finish more portion, only then you can solve the question because whole organic chemistry is correlated with each other, right?
Yes, sir.
That is one thing. Like in case of example, physical chemistry, you just do one topic, you can directly solve question, but that is not possible in case of organic chemistry. Okay. So we are doing chemical property. You know there are three parts of every chapter: how to prepare the compound, how to utilize it, and what are the applications. Same thing we did in haloalkane, haloarine, and we are doing same stuff here. We prepared alcohol and phenol. Now, how these alcohol and phenol are useful for us and their application, like where we can utilize them. So, when it comes to the properties, chemical properties of the alcohol phenol, this alcohol can act as both nucleophile and electrophile. Chinmay, how is that possible?
I'm not sure, sir. I don't know.
Smart.
Sir, cleavage of OH bond will give a nucleophile.
Exactly. Example, we have this. If y- it form like this and release as positive ion, you can say it is a nucleophile. When it is releasing as positive ion and there is a breaking, like bond break between O and H, right?
Yes, sir.
But when it acting as the electrophile, what will happen? This alcohol will react with the one as positive ion, and once it react with any positive ion, you can take any molecule. Example CH3OH. So what will happen? H2O will go out and CH3 positive will remain. Now this can react with any other molecule and form the product. What we are trying to see is carbon and oxygen bond is breaking and now it is electrophile. So it all depends which bond is broken, whether it is oxygen or hydrogen. If hydrogen release, nucleophile. If complete H2O is removed, then electrophile. Any doubts in me?
No, sir. Understood.
Next is like very important for us is acidic property, acidity of all the alcohol and phenol. Smarth, what is the common way how you see like these are the factor affecting the acidic property of any organic compound? I'm not talking about only this in general.
So stability of conjugate base.
Stability of conjugated base. Yeah. So uh, what we are seeing, example, you have any acid. Example, we are considering this is a acid. So what it will do, it will release as positive ion, correct? So if this is a acid, after release of H positive ion, it will be conjugated base. So Chinmay, if we take base, what exactly it will form?
Acid, sir.
Yes, conjugated acid. Remember,
Conjugated.
acid form conjugated base and base form conjugated acid after releasing OH negative ion. Okay, when we are talking about acid and base, Samarth, what are the different way how we define acid and base? There are
Sir,
three methods.
Lewis theory, Bronsted-Lowry theory, and one more is
Arrhenius,
I forgot the name.
Arrhenius.
Yeah,
So,
Arrhenius theory. Yes.
Chinmay, according to Lewis concept, what is
Yeah.
acid?
So according to Lewis concept, acid is electron pair acceptor and base is electron pair donor.
Electron acceptor molecule. So it means base will donate electron.
Yeah, sir. Base
Samarth,
will. Yeah.
yeah. Continue. Bronsted Lowry concept. Samarth, what is acid?
Sir, which gives a proton.
Release as positive ion.
Yes.
What is base?
Acceptor of H positive.
Accept as positive. Chinmay, what is Arrhenius acid?
Sir, Arrhenius acid is substance which dissociates in water to produce H plus ions.
Yes. This
And
is
base is
important. In water, they release as positive ion, and base is
OH minus ion.
yes. In water, they give OH negative ion. And so base electron donor. So these are the three concepts based on the um, depend what is the criteria. Lewis acid, example BF3. It does not have any S positive ion. In that case, we have to see whether it is electron deficient or excess electron are present there. Right? Because most of people say that acid it means as positive should be present in it. No, it's not necessary. In case of water, we use Arrhenius concept, release of as positive ion acid, very like basic, conventional. Bronsted-Lowry, where we talk about acceptor of S positive and donor. Example, Chinmay, if you take ammonia, this accept as positive ion and forming ammonium ion. Is it acid or base?
Sir, it's base, sir.
It's base. So it accept as positive ion and it is base. So this is based on the Bronsted concept.
Yeah,
Okay,
sir.
Bronsted-Lowry concept. So this is given where exactly? It is given in the chemical bonding as well as you study about this in the ionic equilibrium. You also study in the gas state sometime. Okay. So one of the method how we can identify react with the metal and release hydrogen gas. Okay. Why? Because if H positive is released, two hydrogen are released, then they will form hydrogen gas. So if alcohol or phenol are acid, they will react with metal and they will release hydrogen. Okay, this is one criteria of any acid. You are not bothered about the alcohol phenol. This is the one part. Just keep any acid when react with metal, release as positive ion, you will call it as acid. Example, uh, Samar, if you take CH triple bond CH and it react with the sodium, what will happen?
It releases H2 and Na2C2. No, we get two NaCH and
Something
H2.
like that.
Yes, sir.
Like both can be produced, one can be produced. So what is happening in this case? This alkyne is reacting with the sodium and then releasing hydrogen. Can we say this alkyne is acid? Chinmay?
Yeah, sir.
Yes, it is, and this is what given in your alkyne topic. Got it? Acid. It is a good acid because it is reacting with the sodium. And that's why every time I mention you, we are not just doing alcohol phenolic, we are doing full chemistry together. Next example in this case, if you take any, what do you say, is ROH and react with the sodium. So what will happen? RO negative Na positive will be there and half hydrogen gas will be produced. Correct? Same way, phenol also react with the sodium or other metal and it will produce O negative Na positive and it will produce hydrogen gas, right? Make sense? So
Yes.
this is one method. Any acid reacting with metal producing hydrogen is we can justify okay this is acid. You can also see in the form of this salt. Chinmay, what is neutralization reaction?
Sir, acid and base will combine to form. No, 1 minute, sir.
Yes, you are on the right track.
Sir. Yeah, sir. Acid and base will react to form salt and water, sir.
Yeah. So this is the basic reaction you must have studied in 8th class or 10th class, right?
Yeah.
When acid react with the base and form salt along with the water. So this is neutralization reaction. In thermodynamics, thermochemistry, you have heat of neutralization as well. Right? Like this is one of the important concepts. Right? Uh, Samarth, if you have to summarize thermochemistry in shorter version, what is the conclusion of thermochemistry?
The exothermic enthalpies are negative and endothermic enthalpies
Exothermic,
are
endothermic are positive and exothermic are negative. This is one convention. Most of time when you are calculating any heat, any kind of enthalpy of heat, you will see delta H is equal to any change in enthalpy of product minus reactant, right? Usually this is the thing given for any reaction. You are calculating any kind of enthalpy of heat or heat, so product minus reactant. But there are two exceptions, and most of time question are asked only from those two topics. And those exceptions are first heat of combustion and second in bond dissociation energy, bond energy or bond dissociation energy. Trust me, if you know only this segment enough to finish your bond dissociation energy, enough to finish your thermochemistry. Because every time you will write the reaction, like energy will be given, you will calculate every value. But ultimately, formula is this. Any change you are calculating, product minus reactant. But in these two cases, heat of combustion or dissociation enthalpy, here, if you calculate change in the heat, it will be the reactant minus product. Samarth, you read the same thing in thermochemistry?
yes, sir.
Any other energy, whether you take energy of formation, heat of formation, then neutralization, lattice energy, any kind of energy you take product minus reaction, except this two. That's all. Right. So what Chinman, now you tell me if we have a chemical and we don't know whether it is a acid and base, acid or base. You take this chemical, you add base in it. If it is forming salt and H2O, what does it mean?
So it means that it is an acid.
Exactly. Same thing is happening in case of phenol. Example, if you take phenol, react with NaOH. So what will happen? It will form salt, O negative, Na positive, and also it form H2O. Now you tell me, can you say phenol is acid? Because it is reacting with base, right? Because it is reacting with the base. So these two methods, whether you take neutralization reaction or you take metal method, in both situations, alcohol and phenol are acid. Alcohol and phenol both are acid, both qualify the criteria of acid. Right? There are other methods also. Example, if you take base, any base you take, when it react with alcohol, what will happen? It will release as positive ion and
Yes,
it will be
four.
negative. So can you say if this is a base, this is acid? Cinema, what is this?
So salt.
Conjugated acid.
Oh yeah, yeah, yes.
Base will form conjugated acid. And Samarth, what is the second part?
Conjugate base.
Conjugated base. Acid form conjugated base and base form conjugated acid. Okay, this is the basic thing. Got it? Next part, very popular, extremely popular. Like you can expect one question usually from this part: acidity of either alcohol or phenol. So, Samarth, based on the organic compound GOC you have studied, tell me the basic criteria in case of acidity and basicity, how you decide whether a compound is more acidic or basic.
The lone pair should be less available for acidic.
Yes. So what happen? Example, if you have any electron donating group, okay, electron donating group will reduce acidic character, and electron withdrawing group will increase acidic character. You can make it ulta also. If electron donating group is decreasing acidic character, it means it will increase basic character. And here same thing. Tell me any doubt, because through this we are not just covering alcohol, phenol, ether, but also in amine you will have same thing. Make sense?
Yes, sir.
Now we have to justify why. What is the role? Chinmay, can you elaborate?
No, sir, not sure.
Samarth? Example, if you take NO2 and here you have CH2OH, what will happen?
Sir, O minus and H plus is dissociated,
Okay,
and charge will, because of electron withdrawing nature of NO2, charge will be delocalized from
charge
oxygen.
will be delocalized.
So oxygen becomes less reactive.
Oxygen become less reactive. Okay. So one thing is this NO2 group is electron withdrawing group. Okay. Second thing, here acidic character means easily release of this bond, like breakdown of bond and release of as positive, and then it will become O negative. Makes sense. Now imagine if this electron withdrawing group is attracting electron from this group, because it is electron withdrawing means withdrawing electron from this, then it means this oxygen will try to donate some electron toward the NO2. I'm not saying toward carbon. It is because of the NO2 group, right? If this is happening, what will happen? It will withdraw electron from the oxygen, will have positive charge, and continuously oxygen will withdraw electron from the hydrogen. So there are two things. Remember, example, you have OH bond. I'll explain only this part first. You have this OH bond. If this bond is breaking, then H positive will release easily and more acidic character. If this bond is stronger, then hydrogen and oxygen will be closer to each other and release of hydrogen is difficult. Any doubt in this concept?
No, sir.
Okay. So if bond example, if this oxygen have shortage of electron, shortage of electron. So what will happen? Example, NO2 is withdrawing electron from CS2 and then oxygen. What will happen? Oxygen will withdraw electron from the hydrogen. And once oxygen withdraw electron from the hydrogen, oxygen will have negative charge, hydrogen will have positive charge, and hydrogen H positive ion will be released. And easy release of H positive ion is means more acidic. Tell me, any doubt or should I explain this again?
Understood.
Tell me.
Sir, the last part, sir. The last part. The
Yes.
shortage of electron.
So once we withdraw electron, can
From
we
an
say electron amount on the oxygen will reduce?
Yeah, sir.
So electron withdrawing group will reduce electron density from oxygen.
Yeah, sir.
And once this electron density on the oxygen is reduced, this oxygen in turn will try to attract electron from the hydrogen,
Yeah, sir.
right? Oxygen withdraw electron from hydrogen, correct?
Yeah,
So
sir.
it means oxygen will try to carry negative charge on it, hydrogen will carry positive charge on it. And can we say the polarity of OH bond will increase? Positive negative ion will increase between
Yeah.
OH bond. And if this polarity is increasing, it means H positive will be released easily.
Okay. Understood.
H positive is released easily. Now we'll see another side. Another side is that if you take any donating group like CS3 and then you have normal CH2OH, OH. So what will happen? Here you have electron donating group EDs. This electron donating group will give electron to the oxygen. Now, Chinmay, you tell me if oxygen is getting electron from electron donating group CH3, will it withdraw electron from the hydrogen?
No, sir.
No.
It won't.
Then bond
Ah,
between the hydrogen and oxygen will remain same.
yeah, sir.
Can it easily release as positive ion in this case?
Yeah, sir. No, no.
No, no,
No,
because
sir.
it
Because
bond is same, it is not releasing as positive ion.
yeah, sir. Bond will be stable, so there will be no release of hydrogen gas.
Exactly, exactly. So acidic character is all about the how this bond is there. If bond is broken and H positive is released permanently, it means more acidic character. If bond is strong, H positive is not released, acidic character is less. Make sense?
Yeah, sir.
So now you can make it shorter. Electron donating group will increase electron density on oxygen, and when electron density on oxygen is increased, then polarity between the OH bond will decrease, and it means H positive ion will not be released easily. Okay. Example, Samarth. Now you tell me if you have these compound. CH3OH, CH3CH2OH, and CH3CH, CH3OH. In which condition you have maximum acidic character?
Sir, in methanol, sir.
Methanol. Cinema, any doubt?
No, sir. Understood.
Okay, so then you have one more question. Example, you have CH3OH, you have CH2OH, and then here you have chlorine, and then you have CH2 and NO2OH. What is the sequence of acidic characters in?
Uh, Not sure, sir.
Try once. What is the impact of electron withdrawing groups in acidic character?
Sir, electron donating group will increase density, so it will be more acidic.
Less acidic.
Less
Just
acidic.
remember this one thing.
Yeah,
Electron withdrawing group increase acidic character. Means donating
yeah,
group will be ulta.
yeah, sir.
Okay. So here chlorine and NO2 both are electron withdrawing group. Both are electron withdrawing group. So now you tell me what should be the sequence. Okay. Electron withdrawing group increase acidic character. Just remember this word.
Yeah, sir.
Got it?
Yeah, sir.
And for JEE, you will not have this simple question. There will be different thing will be asked like remember minus I effect, minus M effect, both will increase acidic character.
Yes, sir.
It means they will decrease basic character. Same way, my plus I effect, plus M effect, and uh, plus H effect. All three will reduce acidic character, and it means they will increase basic character. So I am not talking about only acidity. Parallelly, we are doing basic. Just remember, you should know only one thing, Chinmay. Every other thing is ulta. Example, if you simply know a electron withdrawing group increase acidic character, it means donating group will reduce the acidic character. Make sense?
Yeah, sir.
If electron withdrawing group increase acidic character means basic character will. If increase acidic character, what will be the impact on the basic character?
Decrease, sir.
Decrease. Okay. So that is the thing. Just remember this. Withdrawing group increase acidic character. Donating group will be ulta. Basic group will be ulta. Makes sense.
Yeah, sir.
But as I mentioned, J will ask more tricky question. Example. Uh, Samarth, if you have this OCH3, 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 which one will have most acidic character?
Sir, meta.
Meta. So, guys, you have to understand two factors are acting together. Chinmay, what do you mean by inductive effect?
Sir, inductive effect. Yeah, sir. So, in inductive effect, how do you say, sir?
Hmm.
The what do you tell? Permanent polarization of
Polarization.
yeah molecule
Hmm.
will be due to difference in electronegativity
Hmm.
of the adjacent atoms.
Correct. Correct. Example, if you have carbon-carbon chain and any molecule is attached and there is electronegativity difference. Example, if it is halogen, then you know this will have partial negative, this will have partial positive. So this polarity due to difference in electronegativity is inductive effect. So there could be both things. Electron donating group can be present, electron withdrawing group can be present, right? Example, if you have NO2 group, then you will say it will have minus I effect, withdrawing group. If you have CH3 group, it is electron donating group, then you will call it as plus I effect. Any doubt? But
No, sir.
my purpose, why I'm talking about inductive effect is that it is distance dependent. What does it mean, Smart?
Sir, after 2 or 3
Hmm.
carbons, it becomes ineffective.
Exactly. It means you can see this uh, impact in the short distance. The more distance you go, the less inductive effect will be there. Example, if you take same situation, you have this OCS3, this OCS3 meta, and this OCS3 para. Just give me a minute. Hello, I'm taking class right now. And like, are you in hostel or you are outside? So you can call later, right? Like we can talk later. Yeah, once I'll be free, it will be like bit late, around 10 to 11, I guess. But I'll definitely call you. Okay, sure. Okay. Hmm. So if you are talking about only inductive effect, nothing else. I'm not talking about resonance and all. So Chinmay, which is the closest out of ortho, meta, and para? If you talk about inductive effect, this is ortho, this is meta, this is para. Chinmay,
So, which is closest?
closest molecule.
Sir, ortho.
Ortho. If you have to tell me where you will see maximum inductive effect, so what will be your answer?
Don't know.
Try to correlate. It is distance dependent. Less distance, more inductive effect. Far away, you will not see an impact. So where out of ortho meta para you will see maximum inductive effect.
Sir, ortho only.
Exactly. So inductive effect will be maximum on ortho, then meta, then para. It is always true, Chinmay. Always.
Okay.
Okay. Doesn't matter whatever the situation. Inductive effect is always like this. It will be maximum in ortho and minimum in para because of the distance. Now we have to decide whether this OCS3 group is electron withdrawing group or electron donating group. For withdrawing group, we use minus I word. For donating group, we use plus I word. Example here. This is electron donating group. This is electron withdrawing group. Samarth, now you tell me, is OCH3 electron donating group or electron withdrawing group?
Donating group, sir.
Withdrawing group. minus I effect. It have very strong resonance effect plus M, but minus I,
Yes, sir. Plus and minus.
right?
Yes, sir.
So because uh, OCH3 have oxygen and oxygen will withdraw electron from the benzene ring. So you will say this group will have minus I effect. Chinmay, any doubt?
No, sir.
So it means where you will have maximum minus I impact, ortho, meta or para, Chinmay.
Uh, Sir, meta.
Ortho.
Ortho, yeah. Make,
You
yeah.
have this sequence on the screen, right?
Yeah, sir, yeah,
It-
sir.
Now you tell me out of these three molecules, if you just consider inductive effect, we don't know what resonance is, where you will see maximum acidic character. Chinmay, if you are considering only inductive effect based on inductive effect minus I effect, what will be the sequence?
Uh, Not able to correlate, sir.
Try to answer. You have to, because same thing, whatever written here is same thing. You know minus I increase acidic character, right? Electron
Yeah.
withdrawing group increase acidic character and minus I means electron withdrawing group. Now you tell me what should be the sequence for acidic character in this situation? Only based on the minus I. Chinmay. The reason why I'm asking you again and again is Samarth did GOC recently in class. So he have basic idea. You probably have missed this. So that's why I don't want you to miss anything from GOC.
Sir, is it
This is
ortho, para, and then meta?
exactly it is. It will be like first have maximum acidic character, then second, then
Yeah.
third. Samarth, any doubt in this?
No, sir.
But Samarth, do you think only inductive effect is sufficient here?
No, sir. Plus R effect is stronger.
Yes. So that's why Chinmay will talk about one more uh, effect that is known as resonance effect,
Yes.
also known as mesomeric effect. Just give me a minute. Hello, hello, Anji. Unit and measurement and motion in 1D. Hmm. And motion in 1D. Capital D. 1D. हाँ हाँ हम्म ओके हो गया रेडी जल्दी भेजो so this resonance effect is also known as mesomeric effect. That's why I was using this word. This resonance effect is also known as mesomeric effect. So example, Samarth was using word R. I am using word M. Doesn't make difference. Both are same thing. Okay, it's your choice how you want to use it. So you can say this is R effect or this is M effect. Same meaning. Resonance occur when there is a alternative single bond and double bond, something like that, but not always. Right, Samarth? Samarth.
Sir?
Always, if you have conjugated system, alternative single bond, double bond, is it the only situation for resonance?
Sir, alternate between charges is also possible.
Yes, so this is conjugation, alternative single and double bond. But not only this, even if you have example this, and then you have like
Minus.
positive charge here or negative charge, then still it can have the like same impact of resonance, right? Or it have negative charge. Got it? Because this electron of the positive, like in case of negative, will rotate in the same way. Example, you will see if you have a ring like this, here you have double bond. Here you have either positive charge or negative charge. Still you will have resonance, right? Correct?
Yes.
That is a different thing, whether it is aromatic, not anti-aromatic, how is a different topic altogether. But at least resonance can happen alternate single bond, double bond, or with the carbocation or carboanion, right? So this is resonance effect. Resonance is highly stable. If you have, like we also talk about third effect, but before that, Chinmay, like how we did electron withdrawing group and donating group in inductive effect, same thing happen here. If you have any electron donating group in resonance, then you will call it as plus M effect or plus R.
Oh,
And if you have electron withdrawing group, same manner, you call it as minus M or minus R. Okay? Very
yeah.
stable. And even in the phenol, we are going to talk about there are 5 resonating structure in phenol. That's why it's highly stable. Phenoxide ion is highly stable because of the stable structure and uniformity. So we're going to talk about the same resonance effect. Okay. So resonance effect is the conjugation. It's like continuously delocalization of the pi electron. You can say resonance is delocalization. Delocalization means continuous movement. Delocalization of pi electron. If you compare with the inductive effect, in inductive effect, we were having displacement of sigma electron, sigma bond. Here we have pi bond. Pi bond is continuously changing its position. Okay, example, here this molecule can have movement and like this. Did I make mistake in this, Samarth?
The electron won't travel from one edge to the other, I think. Sir. I mean, plus charge won't go from one edge to other.
Yeah, that's what like I want to translate. Was it like this? If you have double bond here, then
So
it
then,
can transfer to this, right?
sir, before only it was correct, but I think
Because let me check it again. If we are making any mistake, one, two, three, four. Example, we had negative charge here. Sorry, double bond and positive charge. What will happen? This one electron will go here. Like both
yes, sir.
this pi electron goes here. So what will happen? It will become positive. This will become negative. right? So what will happen? It will be like this double bond, correct? Seen many doubt.
No, sir. Understood.
So what is happening? This pi electron are moving to the next carbon. Any molecule that take electron will have negative charge, and this negative and positive charge on the carbon will make another bond due to the complete transfer of electron, right? And molecule that donate electron will have positive charge. Samarth, is this correct?
Yes, sir.
Yes, it is.
Not.
So that is what delocalization of pi electron in this case. Okay, delocalization of pi electron in this case. Move to the what is the specialty in case of resonance effect? It is very strong, very strong. If you compare two effect, like you have resonance effect and you have inductive effect, which one will be stronger? Answer is always resonance effect. Resonance always have priority because it is permanent effect and stronger role, right? Like some of your friends are temporary, some are permanent. You know them. So it is like permanent have like always carry the maximum weightage for you compared to the temporary friend for whom you just say like hi bye. Correct? And Chinmay, one thing, if you take ortho and para position, resonance effect will be exactly same. It means resonance effect on ortho will be same as resonance effect on para.
Okay.
Always. So example, in case of inductive effect, there was a role of distance. Here we don't have any role of distance. Got it? What happened in case of meta Samarth?
Well, meta does not provide conjugation.
Yes. In case of meta Chinmay, there is no conjugation, no resonance. That's why uh, resonance effect on meta will be zero. There is no resonance effect on this. So two, three basic thing about the resonance is also known as mesomeric effect. There is a alternative single bond, double bond, how we see in case of benzene ring, alternative single double bond and resonance. But it could be related to the positive and negative charge as well. Okay. Example in this case, how we gonna do? Let's say this. And this is what I do. Like I can't remember all this reaction. It's just I am randomly writing any example and seeing whether it is correct or not. Example. Here, if this is donating electron, then carbon will have a negative charge and this will have positive, positive, negative charge will form double bond. So what will happen here? It will form double bond. This is carbon. This carbon will have negative charge. Samantha, is this correct?
I think so.
It is.
Yes. Okay. So
Okay.
that plus comes after bond is shifted, right?
Yeah. So plus minus will form a bond. No, is this correct, Samantha?
Hello, sir.
Hello.
Hello. Yes, sir. Now I'm able to hear. I lost you
Yeah.
for.
Is this correct?
Yes, sir.
But if see, because I do like I understand one thing. When I'm saying so many things, I can make mistake in few things. That's why you did this topic, and I'm asking if I'm making a mistake. Let me know. I would be happy to accept. Yeah, it could be mistake. Okay, so Chinmay, tell me, do you have any doubt in the resonance effect?
No, sir, but I'll have to revise once again.
Yes, it is really, really important to, because why I taught this in this chapter, alcohol and phenol, especially in phenol, we have this topic resonance.
Yeah.
Okay. Second thing, key in case of resonance, we have delocalization of pi electron. Pi electron is moving. Inductive effect, sigma electron is moving. Resonance effect at ortho and para are exactly same, but meta position it is zero. So must based on this, tell me again what is the acidic character in this case.
So meta is highest, second is ortho, third is para.
Meta is highest. So here you have minus I effect and plus M.
Yes.
Here only minus I, and here both minus I and plus M. This, you know, minus I is strongest at ortho position and minimum at para position. Meta effect on ortho and para is exactly same. So yes, answer this is correct. This is first, second, and third. Now, Chinmay, see, this is the neutral position. What is happening in second case? Minus I impact is increasing acidic character. So it is positive. So maximum is second. Then in first case, what is happening? Inductive effect is increasing acidic character, but resonance effect will decrease acidic character more because M effect is stronger than inductive effect.
Yes.
In para position, again same thing. Ki resonance effect is stronger than inductive because at para inductive effect is less. So in that case, because M is exactly same, now we will compare inductive effect Chinmay.
Yes.
No doubt both will be less acidic, but we want to understand which one is the lowest. Because ortho position have stronger inductive effect, that's why first and then third. Any doubt, Chinmay?
No, sir.
This
So my
kind of
question,
question you will
ortho.
get more rather. Yes, Chinmay?
Okay.
Any doubt?
No, sir. Understood.
Samat,
Yes, sir.
any doubt?
No, sir.
You said same answer, no, or it was different?
Sir, I told meta, ortho, and then para.
Para.
Yes, sir.
So this kind of question, Chinmay, you get where you will be confused between two factors together. You never get easier question. Ki, okay, one ortho, sorry, one electron donating group, one electron withdrawing group is given, and you have to compare. It's easy. Example: if you take simplest example, you have CH3 OH, you have CH3 CH2 OH, and you have uh, CH2 OH, and here NO2, and where you have maximum acidic character. This is the easiest version. Chinmay, what is the answer?
So first methanol.
Okay. Here you will not talk about resonance effect, only inductive effect. Plus I minus I. This is middle one is normal.
Uh,
Electron withdrawing group increase acidic character. Okay. Electron withdrawing group increase acidic character. So this is the simplest
yeah, sir.
answer. The withdrawing group increase acidic character and donating group will decrease. So this is about acidic character. Okay. Acidic and basic character they ask a lot, a lot. Very popular question this is. Acidic and basic character. Okay. Got it?
Yes, sir.
Then after that, phenol. Like we know, phenol is also acidic. But Chinmay, now you tell me you have three options. You have water and you have alcohol. Which one should be more acidic out of water and alcohol?
So obviously alcohol.
Alcohol will be more acidic.
No, sir, they're weaker acids than water.
Weaker acid than water. Why?
So same thing, sir, because of electron donating in nature.
Exactly. Now, because of this explanation, everything is looking easy,
Yeah,
right? Because
yeah, sir.
here we have hydrogen normal and R group is electron donating group and electron donating group decrease acidic character. For board, that is more than sufficient. In board, you will get the easiest question. Withdrawing group increase acidic character, donating group ulta. That's all.
Yeah.
If you compare this three situation, this is first, this is second, and you have phenol in third. Chinmay, what will be the answer?
Sir, phenol will be more acidic than alcohol and than water.
Then water. Why?
So same thing only.
Yes, but why? Tell me in detail. Because in board they will ask question. Why? For 2 marks.
Alcohols are less acidic than phenols because, sir, is it due to resonance, sir?
So resonance is one factor, but there is other factor as well. Oh my-
Sir, electron donating group decreases the acidity of phenol.
What?
Sir, does the electron donating group decrease the acidity of phenols?
Do we have electron donating group in phenol? OH is same in both cases. There is a difference of at one place we have R, in another situation we have benzene ring. Samarth, what is the role of benzene ring? Is it electron donating group or withdrawing group?
Sir, it depends on oxygen.
Huh? OH is same in both the situation, isn't it?
Yes, sir. But OH can make partial bond, so it will have positive, partial positive.
Yes, it is. So there will be both effect plus M and minus I, even in the phenol, right? But in this situation, phenol is more acidic. Why? Because this is electron withdrawing group. How do we know compared to alcohol? Because in alcohol you have R, means R have carbon and carbon will be sp3 hybridized. And here carbon will be double bonded to sp2
Oh,
hybridized. Tell me, if you have sp3 and sp2, which one is more acidic than
sp2.
withdrawing with sp2? So Chinmay, this is the basic rule. If you have this CH3 single bond CH3, CH2 double bond CH2, and CH triple bond CH. And anybody ask which one is more acidic? Because hybridization decide the electronegativity. Here in first situation you have sp3, sp2, and sp. Got it?
Yes, sir.
So it is electron withdrawing group. That's why phenol have maximum compared to even uh, water. So if you have to compare, it will be third maximum, then first, then second. Acidic character is very popular question. Okay, so that is where we will stop. But to be honest, acidic and basic character in general is finished. We have to discuss some specific case, but majority part of acidic and basic character is finished, except we'll talk about Ka and Pk next class. So now guys, you tell me, without finishing 11 portion, without understanding GOC, can you do those chapters, especially alcohol, phenol, ether, and aldehyde carboxylic acid,
No,
or
sir.
any organic chapter?
No, sir.
We can't. That's why, Chinmay, go through this inductive effect resonance once again, ask more questions. And that's why in next class, I'll give dedicated 15 minutes to ask more questions. Chinmay, I'll ask what I taught in today's class. Samarth, for you, I'll ask difficult question from GOC.
Yes, sir. I'll revise.
Okay. So make sure every time I'll make it tougher for you. Like Chinmay, next time if I'm asking you, I'll ask you GOC tougher question.
Okay.
So though I'm taking common class for both of you, but still I'll keep your level different. Example, Chinmay, every time I'll increase your level, and in the end it will be same for both of you because you both will reach to the same level.
Yes, sir.
Okay, but we are gonna do everything, whether it is acidic character, different concept, resonance. Actually, I missed hyperconjugation effect, but there was a reason. Because if I add too much of GOC, then you will feel like, sir, you are teaching us GOC rather than alcohol phenol ether. That's why I try to stop here. Tomorrow we'll have slightly longer session. Be prepared for it. Read well, and I'll ask question from the whole chapter.
Okay, sir.
And
Yes,
here
sir.
we are doing question itself. Like there are in organic this kind of question they will ask. They will give three compound. They will ask which one is more acidic.
Oh,
Okay.
Yes,
yes, sir.
Yeah.
Yes,
So
sir.
that's all for today's session. Uh, See you tomorrow. Prepare well from this chapter because I'm gonna ask question. I'll share